All right, we are doing the fifth and final video on the 5 formulas. The last one I affectionately call 5-ULA. All right, so what is the 5th formula? Let's pretend in our headsies we're rolling downhill. Rather symbolic, isn't it? But there you are at the top of the hill. When you initially start, your velocity is 0 meters per second. That's your initial velocity. Your position on an axis, I'm going to call 0 meters. Okay? What you'll notice then is as you roll downhill, there's our VF. And, I don't know, it doesn't really matter. Let's pretend in our headsies we're going 6 meters per second by the time we're at the bottom of that hill. That's quite a velocity. XF, let's say it took 10 meters to get there, 30 some odd feet. The acceleration is going to be our goal. And here's the key to knowing when to use 5-ULA is when you just don't have the time. Okay? When you just don't have the time, time's not given, it's not asked for, it's not mentioned, there's nothing in here that told you about the time. You don't have the time. That's the key to 5-ULA. All right, so your acceleration is the goal. So what I'm going to do again is list the formulas that you know and see if any one of these could answer the question. You have an XF, sorry, is equal to XI plus VT. Again, this is only true if you're not accelerating, and so this can't be the formula. Formula 2 is the average velocity is the initial plus the final divided by 2, and we're not asking about our average velocity here. I mean, you can get it. You can tell the average velocity is 3, but that's not going to help us. This question is asking about an acceleration, so I'm not going to use that one. Formula 3 is the VF is the same thing as the VI plus AT. So I have a VF and a VI. Acceleration is the goal, but again, I don't know the time. So there's two things I don't know here, so I can't use that one. And formula is the one where XF is equal to XI plus VIT and 1/2 AT squared. Remember that? Well, I know the XF and XI. I know VI is 0. The time, again, I don't know. I'm looking for an acceleration and I don't know a time. So there's two things I don't know here. That kills that one. So that means there must be a 5th ULA, and that's what I will do to obtain 5-ULA. And I will do the same thing I did before to obtain 5-ULA. Start with Formula 1. Which you know, because I just rewrote it for you, is XF is equal to XI plus VT. And I'm going to do, excuse me, the same thing I did before. When I obtained formula, what I did was I took this V and I put formula 2 there. Alright, so what I'm going to do is that. So you can still see it. I'm going to write XF equals XI. Then I'm going to write formula 2 in purple. So this will be XF equals XI, where formula 2 is. Hang on, let me write the plus. What's in that purple box? I will write VI plus VF over 2. Now I got to multiply it by time, okay? Now, remember in formula's arrival, what we did was we replaced that VF because we didn't have a VF. But in Fivula, remember, in this particular situation, I don't know a time. It's not given in the problem anywhere. So I don't want a formula with the letter T in it. So I'm going to substitute out that T. And what I'm going to do is use formula 3 with time isolated. So formula 3 is VF is equal to VI plus AT. I'm going to get this T by itself, so this T, whatever it equals, will go in that orange box. It'll end up being VF minus VI over A is what T is equal to. And so this time you do quite literally see a swapper tuna T, don't we? What is in this orange box is equal to T, which looks strikingly equal to that T. So I'm going to put it right there. And so what Fivula ends up looking like is XF is equal to XI plus, and then what's in purple is formula 2 here, VI plus VF over 2. And I'm going to multiply that by what's in orange. That's formula 3. VF minus VI over A. Okay? And this is a multiply sign. Okay. So that's the basic setup. Now it's just a matter of simplifying this sort of stuff. What I'm going to do is move this XI over just to get it out of the way for now. So on the left side, I will have XF minus XI. So sometimes they just write it as a delta X because it's a final minus initial. Okay, now what I'm going to do is write this all as one term. And I'm going to not use different colors anymore. I'm going to combine this all into one item because it's a times sign, so I can combine it all. VI plus VF multiplied by VF minus VI. And since I combine the whole thing, the denominator just becomes 2A. A? So now what I can do is multiply the 2A over. Just take that and multiply it to the other side. And so I will have 2A times XF minus XI. Then I will FOIL everything in that numerator. Okay, so I will start out by saying 2A XF minus XI. That equals VI plus VF, VF minus VI. And since those are in parentheses, I'm going to go ahead and FOIL that on this particular page. And so the left side won't change. The left side stays 2A XF minus XI equals, now I got a VI times a VF. So that's just VI, VF. Then I have a VI times a negative VI. That's negative VI squared. Then I have a VF times a VF. That's plus VF squared. And then I have a VF times a negative VI. That's negative VI VF. And you see how this VI VF and that negative VI VF cancel. And the last thing I'm going to do is push the plus button, and that will end up giving us 5 EULA. So I will have VI. Okay, I'm going to add that over. VI squared plus 2A XF minus XI equals VF squared. Okay? Now usually we'll write it the other way with the VF on the left. That's kind of why I did that a little. But anyway, 5 EULA is usually written with that on the left. So let me do that. VF squared is equal to VI squared plus 2A. And sometimes they just write delta X, but I go XF minus XI. This is 5 EULA. So please, holy shnikes, please remember that. That's the fifth and final formula. And you can tell the one letter that is distinctly not present is the time. Okay, so I am going to go back to this initial equation, or this initial situation. VI, XI, all those variables, and I will place them in 5 EULA. So the W in our WISE method, again, is this. I kind of did a combination of a diagram and a variable list. That's a very good thing to do. You can combine variable lists and diagrams in the W phase. So then the I phase is to identify and isolate the equation. Well, we're obviously using 5 EULA, which is the one I just showed you. It is VF squared is equal to VI squared plus 2A XF minus XI. Okay? Now, what will immediately die? We know the initial velocity was 0, and our initial position on the X was 0. Acceleration is our goal, right? Or I could have given you an acceleration and asked for a VF. I mean, it just depends. Not all equations or questions are created equally. They're all created similarly. They're not all created equally. So to get this A all by itself, that's what I just identified. Now I need to isolate. This is going to be what? VF squared, right? Divided by 2XF equals the acceleration. Okay? So VF squared. The VF was given as what? The VF was given as 6 meters per second. That whole thing is squared. You square the letters 2, divided by 2 times 10. And that was meters, was the length of this. So this obviously becomes 36 divided by 20, which you can do that. 36 divided by 20, boom. This equals 1.8. And this is a meter squared per second squared divided by a meter. So that cancels that meter. So this is meters per second squared. Okay? So please know, again, that it is okay to combine a diagram with variable lists. That's what I did here with this W. There's the diagram rolling downhill with variable lists given. This I just, again, showed you how the other 4 formulas were not correct. This, again, was just how we arrived at 5 EULA. There it is. So there's the I, and you isolated. And there's the S to substitute and S to solve. Does that make sense? 1.8 meters per second squared. Well, if you contrast that to the acceleration due to gravity, which is just falling down, that's 9.8 or 10. So rolling downhill, I would say not quite to make sense. 5 EULA.